Now we will explain how to determine the distance of a point from the origin. Point P is a fixed point in space whose coordinates are x, y, and z. Point P does not lie on any of the coordinate axes or planes. Join the origin and point P. We will determine the length of the line segment OP. From point P, draw a line perpendicular to the xy plane. It intersects the xy plane at point A. Join the points O and A. From point A, draw a line perpendicular to the x-axis. It meets the x-axis at point B. The segment OB is equal to the x-coordinate of point P. From point A, draw a line perpendicular to the y-axis. It meets the y-axis at point C. Line segment OC is equal to the y-coordinate of point P. Now look at OBAC. It is a rectangle. Therefore, line segment BA is equal to the y-coordinate of point P. For the right-angled triangle OBA, by Pythagoras' theorem, line segment OA is equal to the square root of x squared plus y squared. Therefore, we can write OA squared is equal to x squared plus y squared. The length of segment AP is equal to the z-coordinate of point P. To help you see this, we will draw a line from P perpendicular to the YZ plane. The line intersects the plane at point D. From D, draw lines perpendicular to the Z and Y axes. The lines meet the Z-axis at point E and the y-axis at point C. OE is the z-coordinate of point P and is equal to AP. Because all lines are perpendicular to each other, we have the following rectangles: OEDC and APDC, making the z-coordinate of point P equals AP. Triangle OAP is a right-angled triangle. OP squared equals OA squared plus AP squared. Substitute for the values of OA squared and AP squared. We obtain the length of line segment OP is equal to the square root of x squared plus y squared plus z squared.